Okay, here is given any real numbers x greater than 0. Okay, show that there exists an irrational number of this. We don't know what is this. Such that 0 less than this and less than x. Okay, so here we have to solve given any real number which is x, given any real number which is x greater than 0, so show that there exists an irrational number like this such that 0 less than this one and less than x. Okay, solution part. Solution part. If x is irrational, then choose okay, done. Then choose this sign. This sign is a very complex, this sign is very complex. This one, okay. This one is equal to x by 2. This sign is equal to x by 2. So clearly 0 less than this. Okay, if x is irrational, then choose this one is equal to this one. Okay, clearly 0 less than this sign less than x. Okay, so here x is irrational. X is irrational number, so that's why this one. So here this means x by 2, that's why it is less than x, and also x by 2 means 0.5x. 0.5x, x by 2 means 0.5x. 0.5x, so it is, I think, greater than 0.5. Obviously it is greater than 0. Okay, it is greater than 0. So this is the meaning of this line. I hope you all understood. Okay, I hope you all guys all are understood this. Okay, so the next part is okay, I am erasing this the whole. I hope you guys noted it down. Pause the video, note it down. Okay, I will not say you again and again to note it down. You have to pause the video and you have to note. Okay, I will not say every time. Okay, so you have to pause the video and note it down. I will give you space for you so that you can note it, but you have to note it down. I will not tell you again and again. Okay, so if x is irrational, if x is irrational, then choose is this one, this sign is equal to x by 2. Okay, since root 2 greater than 1. Okay, and we have 0 less than this one, and x. Okay, so we have this. If x is irrational, then choose this one. Since since root 2 is greater than 1, root 2 is greater than no, so root 2 has a value. Root 2 has a value, and we have 0, and okay. If x is okay, now this is not 2, this is root 2. Okay, this is root 2. This is root 2. Okay, and here root 2 is greater than 1. Root 2 is greater than 1. So we have 0 less than this one and this one. Okay. If root 2 is greater than 1, yeah, then if root 2 is greater than 1, then this one is again less than x. Okay, this one is again less than x. Okay. In fact, there are infinite many irrational numbers between any two real numbers. Therefore, infinite many irrational numbers. Okay, so that means if root 2 is greater than 1, if since root 2 is greater than 1, we have this one. So that means from 0 to 1, there are so many. There are from 0 to 1, from 0 to 1. In that way, there are so much. There are infinite number of irrational number. Okay, so this one is a one kind of real number. This one is one kind of real number. Okay, these are two real numbers, and between these two real numbers, there are infinite amount of irrational numbers. Okay, so from here we have we done. So this is the sign of irrational number. Here we taken given. So this is the sign of irrational number. Here, when we take x by 2, okay, that means 0.5x, and root 2 is also itself is a value. So it will like this, like x by root 2. Okay, it may be suppose it can be x by 3 also, x by root 3 also. Okay, so there are in between 0 to 1, there are means 0 to 1, or from 1 to 2, or from 3 to 4, or from let's say from what to say 22 to 23, suppose I'm taking. There are in between these two real numbers, in between any two real numbers, there are infinite number of irrational numbers. So from this theorem, or from this statement, we understood that rational numbers is dependent on irrational numbers. Okay, so from if you want to go from one rational number, if you want to go from one real number to another real number, so number of irrational numbers will be present between them, between them. So that is, so real number is dependent, not rational number. I'm sorry, real number is dependent on irrational number. Real number is dependent on irrational number. Okay, I hope you all understood. Let's go to the next interesting question. Okay, so now we are now able to solve, or not solve, we are able to understood where the questions are given, but we didn't solve the first question of this number system chapter. I don't know why. So we will solve in future. Okay. Okay. Next is another important or interesting question is here is given that show that root 2 plus root 5 is irrational. Root 2 plus root 5 is irrational. Okay? Here, root 2 plus root 5 is irrational. We have to show. Okay, so this is a question. We have to show. We have to show. So here, the solution is, suppose root 2 plus root 5 is equal to x is equal to p by q. P by q. Sorry, q. Okay. Is a rational number with pq. I don't know what is this. Okay. Let's p by q is an issue. Is it? Okay. First, I want to write the whole sentence or whole statement. Then we will understand it. Understand that there's meaning. Okay. P by q is a rational number. Is a rational number. Is a rational number with PQ with PQ Z. Suppose root 2 plus root 5 is equal to x is equal to p by q. P by q is a rational number with, okay. So what they're trying to denote with this z? What they're trying to denote with this z? Anyone know? I'm also trying to find out what they're trying to say. What they're trying to say. Okay, root 2 plus root 5 is equal to x is equal to p by q. Okay. Okay. You guys think, I'm also thinking, okay? Think. Okay, so they're trying to say that this is a sign of rational number. This is a rational number. So this is a kind of rational number, okay? This is a kind of rational number and PQ is also like this. Okay? So I hope you all understood. So let's begin. So x minus root 2 whole square is equal to 5. So they are trying to denote z. They are trying to denote rational number with this help of a z. Okay. So root 2 plus root 5 is equal to x is equal to p by q, and p by pq is a rational number. That's why x is in relation there. X is a rational number. Okay, is irrational. Okay, we have to find the irrational. Here we have given PQ and X is also their result of addition. Okay, the x is the result of root 2 plus root 5's the answer, addition value. Okay, x and p by q, okay, is a rational number with this. Okay, they are rational number. Now, no, 1 second. 1 second. This is a two rational. If suppose PQ is rational and they are in a dividing position like this, P by Q. P by Q is in a dividing position with X. With X. Now, here P by Q is in a P by Q, P and Q. These are two rational numbers and they are in a dividing position with X. So now, actually, when two rational numbers is in a dividing position, that means that their result is irrational. Okay, so I don't know. Let's go to the next statement or next line. Then we can understand what actually they're trying to say. Okay, so suppose then x minus root 2 whole square 5 is equal to 5. That is x square minus 2 root 2x plus 5. Okay, x minus root 2 whole square, x minus root 2 its whole square is equal to 5. X square minus 2 root 2x plus 2 root 2. 2 root 2, 2 root 2. Okay, 2 root 2x plus 2 is equal to 5. How this 5 is coming? How this 5 is coming? Okay, I got it. Suppose root 2 plus 5 plus root 5, sorry, is equal to x, okay? And suppose root 2 is equal to x minus root 5. X minus root 5 and they are square rooting the both side. They are square rooting the both side. They are square rooting the both side and oh shit, I'm sorry. 1 second. Okay, suppose so this one becomes 5 and this becomes this one. Okay, like x square minus 2 root 2x plus 2 is equal to 5. This becomes this. Okay. Now the $1,000,000 question is we have to show that their addition value is irrational. Their addition value is irrational. This is the $1,000,000 question. This is the $1,000,000 question. So there the next step. Okay, have you guys noted it? So I am using this whole hence x square minus 3 is equal to 2 root 2x 2 root 2x, which gives which gives which gives hey man, how this is possible? What? Okay, in next step they are giving root 2 is equal to x square minus 3 by 2x, a rational number, a rational number. I don't know what is this. I really don't know what is this. Can anyone tell me what is this? X square minus 3 is equal to x square minus 3 is equal to 2 root 2x, which gives root 2 is equal to x square minus 3 by 2x, a rational number. I understood, but how this is possible? How this 2 with x is going means is going to its bottom part. X square minus 3 is bottom part. How is this possible? And also saying it is a rational number. Okay, think. Take 1 minute or 2 minutes. Think. I am also thinking. Okay. Think. Okay, guys. Here. Square minus. Okay guys, I've got it. I think I've got it. I think I've got it. Just a second. I think I've got it. I will solve how this x square minus 3 is coming. Okay. Then here I am going to the previous line, which is x minus root 2 whole square is equal to 5. That is x square minus 2 root 2x plus 2 is equal to 5. Okay, here if we solve this more, then I am writing it again. X square minus 2 root 2x plus 2 is equal to 5. That means x square minus 1 second 2 root 2x plus 5 minus 2. Okay, note it down with me, note it down. X square minus 2 root 2x is equal to 3. Okay, and here x square minus 3 is equal to 2 root 2x. 2 root 2x, x square minus 3 and it's going to root 2x. Okay, so this one is 1, 2 root 2x. Okay, which gives, so hence we are saying hence we are done with this part. Okay, so x square minus 1 second. Okay, this is the second part. Hence x square minus 3 is equal to 2 root 2x, which gives root 2 is equal to x square minus 3 by 2x. A rational number. Okay, here x square, then this one is here. Okay, which gives root 2. Now the question is how this one is coming. I am also thinking how this is coming. I don't know, I'm not trying to find out. I'm not able to solve why. What is this actually doing? What is this actually? The one thing it can be, suppose x square minus 3 by square by 2x. If this is in 2 into root 2 into x, then it can be oh yes. Oh yeah, I got it here. Yes, this one is correct. Suppose this one. Suppose suppose this form x minus root 2 whole square, that means x square minus 2 root 2, 2 means a square, this means a plus b whole square means what, a square plus 2ab, a square plus 2ab plus b square, okay, a and b, okay, a and b. Here the a is, here the a is x and the b is this, sorry, this one, okay, not the square one, only the b one. This is a, this is b, okay. So x square minus 2 into root 2 into x. If we write it in this format, then it will be easier to understand. Then it okay, so this will become 5, no, okay. So this one, and when, and after this you I think you have got it. So this is this, okay. So yeah, root 2 is equal to x square minus 3 by 2, by 2x, okay. So this is this. I hope you all understood. Now okay, okay. So the last statement here is this contradicts the fact, this contradicts the fact that, this contradicts the fact that root 2 is rational. Oh, yeah. So in our previous line we have seen, we have written that root 2 is equal to x square minus 3 by 2x, a rational number. So this contradicts the fact that root 2 is rational. Okay, root 2 is rational because in the where we written that root 2 is equal to x square minus 3 by 2x, a rational, a rational. Okay, a rational. So root 2 plus root 5 is, so root 2 plus root 5 is irrational. Irrational. I don't know what's this. Okay, let me think this last line. Okay, then we will complete our sessions today. Okay, so that means the irrational means that uh, we cannot express or we cannot write it as a write it in a fractional way. Okay, that means root 2 plus root 5 is not p pq. Okay, this is wrong. So its value either it's not value. The p by q means the fractional number is called rational number. P by q, this rational, p by q is rational, but root 2 plus root 5 is we proved that root 2 plus root 5 is not p by q. Okay, is not p by q. So that's why it is a rational number. Oh, so sorry, that's why it is a irrational number. Okay, so hence this is proof that we cannot, the root 2 plus root 5 value, suppose root 2 plus root 5 value is 0.34 something 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 something, or 1.56 something something something. Okay, but not like this, like suppose 2 by 3, not like this. 2 by 3 is a rational number. Okay, but these decimal numbers are all irrational numbers. Okay, I hope you all understood that is an irrational number. Okay, we proved it. So thank you for today. Thank you for joining us. I hope you guys enjoying my classes or lectures. If you have any problems with my lectures or anything, okay, so you can text me or you can write it in a comment section. Okay, I will try my 100% to solve that. Okay, so that's all for today. Thank you so much. Thank you for joining in. Bye bye.